Let's take a look at problem 7. Again, let's just start with the right triangle. We've got a ramp that's 12 feet in length. So you want to look at it like this. If you want to load something onto the ramp, here's the ground. Oh, here's the ground here. And then something has to go up the ramp. And here's the platform up here. The platform is 2.5 feet off the ground, so that means this side of the triangle, 2.5 or 2.5 feet. The ramp is 12 feet in length. This is the ramp, so the hypotenuse is 12. We want to know the angle of elevation of the ramp. Angle of elevation is always the angle being made with the horizontal side of the triangle. So therefore we say, well, we want to know the angle. We know the length of the side opposite. We know the length of the hypotenuse. So whenever we've got opposite and hypotenuse, we're talking about sine. So the sine of the angle is equal to the length of the side opposite, which is 2.5, divided by the length of the hypotenuse, which is 12. So in order to figure out what the angle is, we have to take the inverse sine of each side of the equation. The inverse sine of the sine of theta is just theta. So theta is equal to the inverse sine of 2.5 over 12. And assuming that the answer I have up here is correct, the answer is 12 degrees. The next one, the pitch on the roof of a building needs to be 2 over 9. If the building is 26 feet wide, how long must the rafters be? Again, you may want to look at your right triangle assumptions to see what pitch means and to see what rafters means. The important thing, or the important thing here, is to notice that you're going to have to do two different problems. Let's forget about the building itself and let's talk about the pitch. The pitch means the rise over the run. So the rise over the run is 2 over 9. So if we want to figure out what angle we need in order to have a pitch of 2 over 9, we need to use the tangent. The tangent of the angle is equal to 2 over 9. Therefore, the angle is equal to the inverse tangent of 2 over 9. Now, I don't have that number right in front of me. Here, maybe I can get it. No. So, I will show you what you do with that. Now we're going to take a look at the building. So the building is 26 feet wide. So that means this is 26 feet. Take a look at the roof. Okay, if we want to make that into a triangle, right triangle, then instead of being 26 feet, the base of that triangle is half of 26 feet, or 13 feet. Now we know what this angle is. That angle is whatever we get. Let's make it a different color. That angle is the inverse tangent of 2 over 9. So in order to find the rafter, which is the hypotenuse, we would say we need to find the hypotenuse. We know the adjacent. That means we're going to need the cosine formula. So we'll have the cosine of the inverse tangent of 2 over 9 is equal to the length of the side adjacent, which is 13, divided by the length of the hypotenuse, which is what we're trying to find. So we multiply both sides by h. And we get h times the cosine of the inverse tangent of 2 over 9 is equal to 13. Then we divide both sides by the cosine of the inverse tangent of 2 over 9. So we end up with the hypotenuse is equal to 13 divided by the cosine of the inverse tangent of 2 over 9. And we end up getting 13.32 feet. Finally, we're looking at a swimming pool. This is the length of the swimming pool along here. So that is going to be the 90 feet. The pool at its deep end is 12 feet. But since at the shallow end, it's already got 2 feet, you have to get rid of that top 2 feet in order to be looking at the correct triangle. So this is the triangle we want to be analyzing, where that is the angle. The length of the side opposite is 10, and the length of the side adjacent is 90. And we're trying to find the angle, so if we've got the opposite and we've got the adjacent, we are going to use the tangent formula. The tangent of the angle is equal to the length of the side opposite divided by the length of the side adjacent. So again, you use the inverse tangent so that the angle is equal to the inverse tangent of, that should be 10 over 90, not over 19. So we're looking for the inverse tangent of 1/9, which turns out to be 6.3 degrees.